Dear students, let's start lecture number 6 on the topic symmetric key cryptography of the course network security. This is our outline. First of all, we will revise our previous lecture. Then I'll go through placement alternatives of cryptographic schemes on the network, and then I'll go through link encryption and end-to-end encryption, which is performed over the network, placement of encryption-based approach, and then I'll do the traffic analysis of both these placement alternatives like encryption, link encryption, and end-to-end encryption. Uh, Types of cryptographic function. I'll explain them, that what are the types we have in this in this presentation, and then I'll explain them briefly. Secret key cryptography, or you may also call it as symmetric key cryptography. And then I'll go through the approaches to symmetric encryption, substitution, and transposition. So let's revise our previous lecture. As if you remember that our previous lecture was on classical encryption techniques, but uh, the core concept of uh, that presentation was symmetric cipher model. So I have considered that model. In that model, you have 5 parts. You have a plain text, you have encryption algorithm, you need security key, you need ciphertext which travel along the internet, or the network, which helps to maintain your confidentiality and integrity. And then decryption algorithm, this is the reverse process. I'll explain that with the help of this model. You can see here that in this model, let me have a spotlight. Yes. So you have a plain text. This plain text is uh, passed to encryption algorithm, and you have a security key here. And once you apply encryption algorithm and security key on a plain text, so your plain text will be converted into ciphertext, and then this ciphertext will travel along the communication medium, and then the receiver applies the same secret key and decryption algorithm to get it back. So these are 5 components, plain text, encryption algorithm, security key, and then you have that text which is normally mingled, and nobody can understand without receiver. So this is the 4th one, and then you need decryption algorithm to apply it back to get your message. So now, model of conventional crypto system, like for example, you have a message X, and you feed this message to encryption algorithm, and then the key will be applied on it, and then it travels over the communication medium to decryption algorithm. When X reaches here, which is normally in the cipher form, you know that the key is traveling over a secure channel. You can see here. So the key is traveling over the secure channel and reaches the recipient. So recipient applied the decryption algorithm and the security key to get it back, the plain text. So this is the mathematical way. So I'll explain. Oh, sorry. Uh, Let me have a spotlight. So this is the process. This is encryption is performed, like you have a key and you have a ciphertext. So encryption will be performed, and on the receiver side, you have the same key which travels along secure channel and reaches the recipient, and recipient applies this key and encrypted or cipher text to get the original text back. Oh, sorry. So secure use of conventional encryption. So there are two requirements that you need an encryption algorithm that even opponent or intruder knows that algorithm. He can access, or he can access one or more cipher text as well, but still he not be able to decipher your text. This is the key requirement, because as you know, if you know algorithm, so intruder or a crypto analysis, he can know that algorithm as well. So knowing that algorithm and knowing some of one or more cipher text, he unable to get the confidentiality of your message. So this is requirement number one. And the second requirement is that key must be travel on some secure channel or some secure fashion, so that it not be accessed by intruder or a malicious user. Because if someone recovers the key and know the algorithm, communication will be disclosed. So this will be the more dangerous for the communication model. Cryptography definition, I don't want to go into detail of the definition because I have explained these definition in my previous lecture, but abstractly I can define it that you want to perform secure communication in the presence of adversaries or third party. So if adversaries or third parties or an opponent or a malicious user get that traffic or get that information, he will not be able to understand your communication. So this way you can make your communication secure. These are the dimensions of cryptography. Normally you have three independent dimensions, like what operations you are performing, like substitution and transposition. I'll go into detail of these um, in these topic in my next slides. But briefly, if I mention that what the substitution is, that each element in the plain text is replaced by another element. And what the transposition is, element in the plain text are rearranged. The fundamental requirement that is no information will be lost because they are only reversed or transposed. Most system referred to as product system, you can apply these substitution or transposition twice or thrice to make it more complicated for the intruder or a malicious user. Cryptography dimension. So second dimension is the number of keys you are using. So normally if you are using one key, so this is called symmetric, as we are studying symmetric cryptography. So actually we are here. So we will be studying these next approaches as well. But now we are studying symmetric cryptography. So normally we call it symmetric or a single key or a secret key or conventional encryption. Achha. The way, and the third one is the way in which the plain text is processed. So plain text can be processed as a block of cipher. You can process it as a block or a stream cipher. So in a stream cipher, normally it is processed one element at a time as it goes along. So in the next lectures, we will be going into the specific techniques of that, how block ciphers they are performed, or how block stream ciphers are achieved. We will be studying in our next lectures. Approaches to attack a conventional encryption or a symmetric encryption scheme. So crypto analysis or cryptoanalytic attack, normally this is performed by get the nature of the algorithm, and then you study some of the ciphertext or a plain text, and then get the pattern of that, and you will try to get the key. So once you have the key of the communication, you can understand the meanings of what the sender wants to say to the receiver. Or you have a brute force attack. In brute force attack, attacker tries every possible key on a piece of a cipher to get the plain text back, or a meaningful message back. So this was our previous lecture. Now start our today's lecture, which is on the topic of symmetric key cryptography. Now, first of all, we will study placement alternative, that where and how cryptographic mechanism they are applied over a network. So there are two schemes. One is called link encryption, and another one is called end-to-end encryption. In the link encryption, encryption occur independently on every link. I'll show you this with the help of demonstration in the next slide. One key per pair, most must decrypt traffic between the links. On each link, the traffic must be decrypted. Requires many devices, but pair keys. Transparent to use. Normally, they say transparent to the user, means the user will not be aware of that. Normally, it is done in hardware. End-to-end encryption. Encryption occur between original source and final destination. For example, if the sender wants to say anything to the receiver, so only encryption will be done by the sender, and on the receiver side, or the recipient side, this is performed by the receiver. So in between the network, no decryption will be performed. So one key per user pair, and need devices at the end with shared key. Now, this is the demonstration of that. For example, if the sender wants to say send anything to the receiver, so you have two techniques. You have a end-to-end encryption. In end-to-end encryption, sender encrypt or cipher it, and only receiver will decipher that communication. Over the network, no decryption is performed. Whereas in the link encryption device, sender encrypt, and on each link, encryption and decryption will be performed. Like for example, if the sender wants to say anything to the receiver, so in the link state, sender will encrypt, and on each link this will be decrypted, and whenever it access to the next link, it will be again encrypted, and on the receiver side of the link, this will be decrypted. So on each link, this encryption and decryption process will be performed. Now, this is the traffic analysis, that what is that how we get the trend of that how your communication travels over the network. So in the end-to-end encryption, must leave the header in clear, means your header will be clear, so that the router or the node which gets your message get your information, or the root information, that where your information will be routed next. Whereas the content will be protected. As you know that there are two parts of communication. You have a header part and you have a payload part. Payload part is the information part, and header part is normally used for routing your information. So routing information will be clear for the link between sender and receiver, so that they can easily route your information wherever they want, and only encryption will be performed at the receiver. Decryption will be performed only at the receiver side. Whereas the link state, traffic flow link protects traffic flow from monitoring, because on each link, as the encryption and decryption is performed in a link way, link encryption. So you no node can monitor your traffic, that where your traffic is heading. So in a head in an end-to-end encryption, normally whole network knows that where the information is flowing, or where the information is going to, or to which node. So this is monitoring can be performed in end-to-end encryption, whereas in link encryption protects the monitoring of the traffic. Types of cryptographic function. We have three types of cryptographic functions. Like we have a secret key or symmetric cryptography, where both sender and receiver use the same key for the process of encryption and decryption. Public key function, two keys use, one for encryption and another for the decryption. Whereas a hash function, no key are used. Text is not convertible from the ciphertext back. Normally, this is used for the passwords. I mentioned this in my previous lecture. Secret key cryptography, like for example, if you have a plain text and you have a ciphertext, and then you have a ciphertext and you have a plain text. You know this is performed at the sender side, this operation from the plain text to the ciphertext, and from the cipher to plain text, normally this operation is performed at the receiver side. So you can see here that same key is applied for both encryption and decryption. So they normally this secret or symmetric or conventional cryptography uses single key. The plain text and ciphertext having the same size. This is called symmetric key cryptography. Now, basic approaches to symmetric encryption. So, two basic building blocks of all encryption techniques, like you have substitution and transposition. In the substitution, the letter of a plain text are replaced by other letters or by other symbols. If the plain text is viewed as a sequence of bits or blocks. So normally we view the plain text as a sequence of bits or bytes. Then substitution involves replacing the plain text bit or block pattern with the cipher bit or a block pattern. So normally you can see it as a sequence of bits or sequence of byte. If this is considered as a sequence of bits, so this will be a string cipher, and if this is considered as a sequence of blocks, it is called block cipher. We will be studying these approaches in our next lecture. Now, transposition elements in that is in a plain text are rearranged. Actually, we will also be studying these techniques in our next lecture as well. So these were the references which I have cited. You can go through them and find out more about this lecture if you find anything confusing. Uh, this is question answer. If you have any question, you can ask me through WhatsApp or KCMS, or you can find my email address at the bottom of this slide. So I'll be more than happy to answer your questions. Thank you. With that, we reaches the end of lecture number 6. We will start our lecture number 7 on the symmetric key cryptographic techniques. Till then, Allah Hafiz.